relative solubility, where we will basically compare the solubilities of different salts, different ionic compounds. So how can we compare solubility of different compounds? One measure of that would be Ksp. Usually if the Ksp has a lower value, that means that the compound might have a lower solubility. And why is that? Because if I take a salt, AB, solid, and we dissociate it in water to give us ion A and ion B, what is Ksp? Ksp is product over reactant. So if I have more products, that means my Ksp has a greater value. Mathematically, it's a greater value. That simply means the reaction is going in the forward direction. More ions than the reactant. I have more ions. If the Ksp is a smaller value, that simply means I have less product. So the reaction is going in the reverse direction, or it is going less in the forward direction, which means the solubility is less. But the catch here is, if we are comparing multiple salts, the Ksp values can only be indicative if all the salts basically have comparable Ksps. Okay, if we are comparing the compounds that produce the same number of ions. For instance, if we look at this question, arrange the following salts in increasing order of their solubilities. So these are the three salts given to us. Their Ksps are given to us. Question is asking, arrange them in increasing order of their solubility, meaning increasing order of their X. So first we need to write the lowest, then greater than the greatest of them all. So which one's the least soluble? The one that has the least X. How can I find X? Remember, to find X, we need the relationship between Ksp and X. For AgI, it will dissociate to give me Ag. It will dissociate to give me I. This would be X. This would also be X, 1 to 1. So my Ksp will be X squared. If I do the same for CuI, this will be X. This will be X. Again, my Ksp will be X squared. If I do calcium sulfate, this would give me calcium, this would give me SO4. Again, this is X, which means Ksp is again X squared. Which simply means that Ksp for all of them is X squared, so X is going to be square root of Ksp. So X for this is square root of this, square root of this, square root of this. So mathematically, if I want to compare X's for all, I can also compare Ksp's for all, because all of them are square root. So if the value is if Ksp is a greater number, my X will come out to be a greater number, right? So that's what it means mathematically. And why can I compare Ksp in all these cases, which is comparable to X? Because all of these salts dissociate to give me 2 ions. For all of them, Ksp is X squared. If these salts were slightly different, if they gave me slightly different number of ions, the relationship between Ksp and X would be slightly different, and that's when we cannot compare Ksp. That's when we would have to find X. But in this case, because they all have the same relationship between Ksp and X, just by comparing the values of Ksp, I can arrange the salts in increasing order of their solubility. So the one that has low Ksp has less solubility. The one that has a high Ksp is more soluble. So the lowest Ksp I see is this, which means the lowest will be AgI. Then greater than that is going to be CuI, and the highest of them all is calcium sulfate. Moving on to a next question. For example, arrange the following salt in increasing order of their solubilities. And now if we look, all these salts are slightly different. They all give different ions. For example, Cu and S, this will be X, this will be X. So Ksp here is going to be X squared. But if I take Ag2S, this will dissociate to give me 2 Ag ions and 1 sulfide ion. So this is going to be 2X and this is going to be X. And Ksp will be X times 2X squared, which is 4X cube. Whereas in this case I get 2 Bi ions and I get 3 sulfide ions. So this would be 2x, this would be 3x cubed, 2x squared, which eventually gives me 108x to the power of 5. So KSP here is 108x to the power of 5. Now I want to compare them based on solubility, meaning x, and the relationship of x and KSP is different for all three of them. That's when I cannot just compare the KSPs. I have to solve for x for all of them, and only then I can compare their solubilities. So this is the case when you cannot just compare KSPs to determine their solubility. You have to find their x. So that is because KSP values for these are not comparable to each other, because all of them produce different number of ions when mixed in solution. So from here we will be solving for S for all of them, and this is the value of S that we get. So how would we solve for S? For example, x for this is going to be square root of KSP. X for this was square KSP divided by 4 cube root, and S for this was KSP divided by 108 to the power of 1 by 5. That's when you get this. So you have to find values of x for all of them. Then this has the lowest, then higher, and then the highest solubility. So CuS is least, then Ag2S, then BiS2, Bi2S3. And that is relative solubilities.